Hello friends, this is fourth video in Arduino video series. In this video, we'll learn how to interface LED to the Arduino. So, for connecting an LED to the Arduino, there are two methods. One is source method and one is sinks method. So, in source method, the Arduino pin is allowed to source current to glow this LED. So, as we know, Arduino pin supplies plus 5 volt and the maximum current can supply 40 milliampere, so that will glow this LED. In this method, the anode of this LED is connected to the Arduino pin with the help of this current limiting resistor, and the cathode of this LED is connected to ground of the Arduino. So in this method, this LED will take current from this Arduino pin. In another method called sink method, this method, the external plus 5 volt supply is required to glow this LED. In this method, the anode of this LED is connected to external plus 5 volt supply with the help of current limiting resistor, and the cathode of this LED is connected to Arduino pin. So that means this Arduino pin will sink the current that will be taken by this LED. So in source method, the Arduino pin actually sources the current to glow this LED, and in sink method, the Arduino pin sinks the current. That means it will not supply any current, it will only consume the current, or it will sink the current. So that is the difference. We can use any of this method for glowing LED. So we are talking about this 5 mm LED, which will be actually 3.3 volt up to 5 volt voltage it will take, and the current, maximum current it can take 25 milliampere. So that LED, actually generally this method is preferable to connect this LED to the Arduino pin. So interfacing diagram. So this is our Arduino Uno board. As we have in first video, we have explained the various component in this board and how it is operated. There is a Atmega 328 PIC, digital pin at one side, analog pins are also there as analog to digital is inbuilt. The power in pin, so we can apply external power DC voltage from this 5 mm female jack, and USB, B type USB, you can connect it here for programming, or it can also take plus 5 volt supply from this USB. So from this Arduino Uno board, we will take pin number 13, which is a general purpose digital input output pin. So to this 13 pin number, we will connect an LED. The anode of this LED is connected to that pin number 13 with the help of this resistor, and the cathode is connected to ground of this Arduino Uno board. So this is the interfacing diagram. So very simple, that LED we have to connect to any of these pin numbers with the help of this current limiting resistor. So the value of this resistor in this slide, I have shown you the value of resistor, how to choose it. So it is voltage by current. So maximum voltage will take here 5 volt, and the maximum current will take 25 milliampere. So we'll get 200 ohm of these resistors it will be required. As we have considered 25 milliampere of maximum current for this 5 mm LED, so that resistor becomes 200 ohm. But this is a rough formula, but actually we can use any of this value from 200 ohm up to 1 kilo ohm, because when we take 1 kilo ohm, the output current is very low, but that is sufficient to glow these LEDs. So this is a rough formula, we can say. Okay, now interfacing diagram. After that, the algorithm. So while programming for blinking this LED, so there is an algorithm. So start, then configure port pin 13 as an output pin where LED is connected. We have to set port pin 13 as an output port, Now then send logic high to this port pin. As we know, when we send a logic high, then it will supply plus 5 volt at its pin. Then give a delay of 1 second. So we are writing this algorithm for LED blinking, and this LED will blink for 1 second every 1 second. So again that LED will get low, that is LED will get off for 1 second, give the delay of 1 second, and then go to step 3. So this will run again and again. So LED will on for 1 second and LED will off for 1 second. So this is the algorithm for LED blinking. Now actual code, or we can say sketch, for blinking this LED. As we know, in the second video I explained how to write this code, and the software I have explained, Arduino IDE, it is called Integrated Development Environment. So in this sketch, the void function which run once, so in void function, void setup, I have set pin mode 13 as an output pin, so this will initialize pin 13 as an output. In loop function, we have to on LED for 1 second and off LED for 1 second, and this is in loop, so it will run continuously. So digital write 13 pin as a high, this will turn on the LED and take a delay of 1 second, and again digital write 13 as a low, so this will turn off the LED, again delay of 1 second. So this is a simple sketch for blinking this LED. So let us see practically the connections and the LED blinking. Okay, so this is practical connections of the LED blinking. So this is Arduino board which is connected to this laptop with the help of this USB cable. Now as per our circuit diagram, we have to connect this LED with the help of a series resistor to this Arduino board, and the pin number we have to connect here, pin number 13. This is connected to the resistor. The anode resistor is connected to anode, and the cathode of this LED is connected to ground pin on this Arduino board. So now let us see the code. So as we know the code already in presentation I have shown you. So pin number 13 we have to set as output, then digital write pin number 13 high, turn on LED, then take a 1 second of delay, that means 100,000 millisecond, and again digital write 13 as a low and take a delay of 1 second. So let us upload this program. So you can verify it, it will check for errors, and then we have to upload it. So it is doing uploading. So done uploading. Okay, so let us see that. So LED is blinking for 1 second. So 1 second it is on, and for another 1 second it is off. So this is a simple LED blinking program for 1 second. Now I just make here a little change of delay 100 millisecond, and then upload again. So see the changes. Now LED will blink very fast because the delay now it is 100 milliseconds. So that means in 0.1 second LED will blink. See the difference. Okay, so similarly you can connect number of LED to the number of pins available on this board. So you can make a LED flasher or LED blinking or LED chaser circuit with the help of this. Okay, so thank you for watching. If you have any doubt, then comment on this video. Thank you.